Hello everyone, we are group AsGP27 and we will be demonstrating our object relational database project for Haven Retreat Management System. So Haven Retreat manages different retreat programs, accommodation, retreat settings and their relationships. To support this, we have implemented Oracle object relational features including user-defined types, arrays, nested tables, reference objects, SQL queries and PL/SQL automation. So we'll begin with an empty schema, execute the script session by section, demonstrate the functionality, perform testing, and finally remove every object to verify that our script runs successfully from start to finish. So first of all, before executing our script, we will verify that our schema is empty. So this will confirm that our solution can be built from scratch without any existing database objects. So moving on to section 1. Section 1 creates the object relational components required for our system. So first we create the address object type. Since every accommodation has an address consisting of street, town, postcode and country, grouping these attributes into one reusable object avoids repetition and improves maintainability. Now moving on to accommodation style type. Next we create the accommodation style object type. This represents accommodation styles such as cabin, luxury suite or tree houses and will later be stored in an object table. Now similarly we create a array. Every accommodation has only a limited number of features such as Wi-Fi, spa or fireplace, making a array suitable because Oracle stores a fixed size collection efficiently. Now moving on to tag nested table and collection type. So nested table, this section creates nested table. Retreat settings can have many descriptive tags such as eco-friendly, remote or lakeside. Since the number of tags varies, a nested table is more flexible than a array. Then now moving on to collection type. We finally create a standalone collection type which will later be used by our bulk processing procedure. Now moving on to section 2 sequences. So section 2 creates all sequences. Every table uses its own sequence to automatically generate unique primary key. This prevents duplicate IDs and simplifies inserting new records. So now moving on to section 3 which are tables. So for 3.1 we have accommodation styles. This object table stores all accommodation styles available in Haven Retreat. Similarly in 3.2 we have accommodations. This table stores accommodation information including address, accommodation features and accommodation style. It demonstrates object types, varies and ref objects within a relational table. And in 3.3 settings we have table that stores retreat settings such as woodland or lakeside together with multiple descriptive tags stored inside a nested table. And in 3.4 we have retreats. This table stores retreat programs such as health retreat or weight loss retreat. And in 3.5 we have retreat settings. A retreat can be organized in different settings and on different days. Therefore, this associative table records where and when each retreat takes place. And finally, at 3.6, we have retreat accommodations. Finally, this table assigns accommodation to each retreat schedule and records the available accommodation unit.
Hello, my name is Sensang Lama. Section 4 populates the database with realistic sample data. This data allows us to demonstrate SQL queries, procedures, and testing using meaningful examples rather than empty tables. Now the data has been inserted successfully while maintaining referential integrity between all the related tables.
My name is Pravesh Nial. Section 5 demonstrates how information can be extracted from the event retrieve database. In 5.1, this query combines retreat settings and schedules using inner joins to display complete retreat information. In 5.2, here we generate management reports using aggregate functions such as count, sum, and average. In 5.3, this outer join shows every retreat settings, even if no retreat has yet been scheduled. In 5.4, here we demonstrate Oracle built-in functions including upper, round, and substar. In 5.5, this query relatives values stored inside our address object. In 5.6, this demonstrates REF objects by navigating from the accommodation table to the accommodation style object table. In 5.7, here we retrieve multiple tags stored inside the nested table. In 5.8, this retrieves accommodation features stored inside the array. In 5.9, this query analyzes accommodation prices by style. And lastly, in 5.10, finally, this query combines all major tables to produce a complete have and retreat booking report.
Hello, my name is Sriram Paul. Section 6 automates common operations performed by Haven retreat staff. In 6.1, add retreat setting. Staff can schedule a new retreat without manually writing SQL insert statements. In 6.2, assign accommodation. This procedure assigns accommodation to a retreat. In 6.2, assign accommodation. This procedure assigns accommodation to a retreat while validating user input. In 6.3, bulk load. Instead of inserting many records individually, this procedure uses Oracle's for all statement to perform efficient bulk inserts. In 6.4, report procedure. Finally, this procedure generates a formatted retreat summary using an explicit cursor. In section 7, functions, This function calculates the total available capacity for our building. This function counts how many accommodations belong to a selected accommodation style.
I'm solving trial. And in section 8, there is triggers. Triggers automatically enforce business rules before data is set. In our project, they validate retreat capacity, start time, dates, and accommodation pricing. Cursor. The standalone cursor processes one record at a time to generate a retreat report, and the section 10 loops and cases. Finally, this PL/SQL block demonstrates Oracle programming constructs including for loops, while loops, if statements, and case expression to categorize retreat capacity automatically.
So hello, my name is Samrat Tamlakar. So now it's section 11. So this final section executes our functional test case. So these tests verify successfully operations, invalid input, exception handling, trigger validation, and functional outputs. So So the tests from 11.1 to 11.7, it validates procedures including successful inserts, duplicate checks, foreign key validation, and bulk loading. Tests 11.8 to 11.11 verifies the reporting procedure and both functions. Tests 11.12 and 11.14 intentionally trigger validation errors to demonstrate that our triggers enforce business rules correctly. These results confirm that our SQL and PL/SQL components behave correctly under both normal and exceptional conditions. So after completing the demonstration, we execute the drop section. This removes all the table types and sequences in the correct dependency order so that the schema is returned to its original state. So now we verify the empty schema. So since the procedure and functions were not dropped, we additionally add the script for them and run and finally verify. So this concludes our demonstration. Our project successfully implements Oracle Object Relational Database concepts, including object types, object tables, ref objects, arrays, nested tables, SQL queries, procedures, functions, triggers, cursors, and PL SQL programming. Thank you for watching our presentation.